All right. So again, good afternoon, everybody. I hope everybody's doing well. Um, Today, what we want to do is we want to let me just slideshow. Today, what I want to do is I want to finish up confidence intervals. Have your graphing calculator handy with you. It doesn't matter if it's a TI-83 or TI-84. Just we're going to be using that a bunch today. So this would probably be the first half of class, mostly, roughly. All right, just a reminder, homework number 6 is due Tuesday, next Tuesday, the 27th by 11:59 p.m. I'll take questions on it next class. So I'll start class next time just being like, hey, does anybody have any questions on the homework? And I'll answer them. Just out of curiosity, maybe like just in the chat, how many people have started the homework already? Anybody started yet? Nobody? We got one. Okay, good. The homework, you're totally allowed to use your calculator. The only thing I ask is if you use your calculator on your homework, just input or just type in or write down what you used. So what I mean is like when you go to do the problem, just write something like I used, Z interval, or I used T interval, just something like that. Because a lot of times when students miss the problems, and they use Z interval when they should have used T interval, or they use T interval when they should have used Z interval. And I just like to see that in the homework. So if you use your calculator, just write that down. And then during the second half of class, we're going to start hypothesis testing. And this is our final topic. Woo! Anybody excited about that? We made it. I'm kind of excited. I'm ready for this semester to be over. I'm not sure about you guys. Nobody wants to chime in. Okay. And then only 2 more weeks of class, right? So the last day of class is Thursday, 5/06, and that's going to be exam number 4 on that day. Okay. So those are my announcements. Before I get started with the lecture, does anybody have any questions about any of that?
And is there going to be a review for the final exam?
Yeah, yep. So what I'm going to do is next week. So let me just do this. So if you look at the next week, the 27th and 29th, I'm going to spend doing hypothesis testing. And then on the 4th, I'll finish up hypothesis testing maybe during the first part of class, and then I'll do a review. So yeah, I'll do a review on the 4th. So remember, the only thing about exam number 4 to remember is I drop your lowest exam score from exams 1 to 3, but everybody has to take exam number 4. Okay, that it doesn't get dropped. So there's some good news, bad news about exam number 4. So exam number 4 is the shortest exam. I think there's only 12 questions on it, but the bad news is like each question ends up being worth more points then. So it's a little bit higher stakes in that sense.
And is it going to be cumulative?
Say that again.
Is it going to be cumulative from the beginning of the semester?
Nope. So okay. It just covers confidence intervals and hypothesis testing. That's it. Just the last 2 topics we've been covering. And then I'll also post homework number 7 will just be a review homework. So if you do the review homework, that's like literally the best way to study for it. All right, any final questions before we hop into our amazing lecture today? So last class, this is what we were doing. Last class, we were doing confidence intervals for mu. So confidence intervals for a mean when sigma was unknown. And I showed you, I talked about this new statistical distribution called the T distribution. And does anybody remember, like I showed you a new option in the calculator. Does anybody remember what that option was called? So we have Z interval, and then what was the one for this type of situation called? Alexander has it. Yeah. And calculator, it was this T interval. Okay, so here's this problem. So this is kind of just a review problem from last class. All right, the general social survey, I can't speak today. The general social survey of opinions and lifestyles of U.S. adults, and this is a real survey. Okay, this is conducted by the National Opinion Research Center at the University of Chicago. It's called NORC. It's a real research center that's kind of it's an awesome place for survey researchers. Anyways, a sample of 81 people. Okay, so like let me just tell what you're given. You're given n is equal to 81. Okay, aged 18 to 22, reported the number of hours they spent on the internet in an average week. So like, how many hours did you spend on the internet? Okay. The sample mean, this is crazy, X bar, they said they only spent 8.20 hours on average. Okay, probably this survey is probably pre-COVID because I probably spend 8.2 hours on the internet a day. Okay. Anybody else feel like they spend a ton of time on the internet? Yep. It's that Netflix and HBO Max that's been getting me at night these days. All right, with the sample standard deviation, so sample standard deviation, that's S, is equal to 9.84 hours. Okay. Next, it says construct and interpret a 95% confidence interval for the mean number of hours per week spent on the internet by people aged 18 to 22 in the United States. Okay, so to construct this confidence interval, because you're given S here, all right? Oops, sorry. Because you're given S here, are we going to use a Z interval in our calculator or a T interval? What do you guys think? All right, exactly. Why do we use the T interval here? If you want to share.
The sigma is not known.
Yeah, thank you. Perfect. The sigma is not known. You're given the sample standard deviation. So you're going to use the T interval in your calculator. All right, so let's all grab our trusty calculator. And all you're going to do is you're going to hit the stat button. You're going to scroll over to tests. And you're going to scroll down to option number 8 here. And then you're going to hit enter. So let me ask you this. This is the next question. Are you given the data or are you given the summary statistics? So are you going to use data or stats here? Awesome. Thank you in the chat there. Yeah, you're going to scroll over to stats because you're given the summary statistics. You're going to hit enter. And then if you have anything saved in here, it's from a previous problem. So for X bar, you're just going to replace it. It's going to be 8.20. S sub X is going to be right here, 9.84. N is the sample size. So that's just going to be 81. So 81 here, you're going to type it in. Boop. And then your confidence level. Jamie, sorry, could you explain how to get there one more time? Yep, no problem. I'm going to start over just real quick. So you're going to click the stat button, Jamie. You're going to scroll over to tests, and it's option number 8. Do you see it? Awesome. Boom. Great. So under stats, again, you're going to put in X bar 8.2, S sub X is 9.84, sample mean is 81, 95% confidence, boom. So you're going to put 0.95. And then you're going to scroll down to calculate right here. How many people see that number? You see what I have right there on the screen with me. I got one I do. Got one yes. Okay. Awesome. All right, and that's the construct part right there. So it's 6. I'll just round to 2 decimal places. 6.02 to 10.38. Boom. Awesome. So now we have to interpret this interval. Okay. Would anybody like to, I don't know, turn on their mic and tell me how you interpret this? Like, what is the correct interpretation?
Based on this sample, we are 95% confident the mean is between 6.02 minutes and 10.38 minutes.
Close. It was in hours, so just a little bit of a, but you totally have the right idea here. Based on the sample.
Oh, it's hours. Okay, thank you.
Yeah, it's okay. Based on the sample, we are 95% confident the mean hours adults aged 18 to 22 spend on the internet per week is between 6.02 hours and 10.38 hours. So what this is, I just want to say, and this is a common mistake I see sometimes, it's not 95% of all people aged 22 to 18 to 22 spend between 6.2 and 10.38 hours. Like that's just not true. All we're saying is, look, I don't know what the real mean is, but I'm 95% confident that whatever that real average is of all people aged 18 to 22, so the average of everybody, it's got to be somewhere between 6.02 hours and 10.38 hours. Okay. So let me ask this, at least with your calculator, is it not too bad? If I asked you a question to at least construct a confidence interval on the last exam, I'll answer that question in the chat. Do you think you guys could do this on the exam? And then I'll answer the question in the chat. What do you think? I got one yes. I hope so. You'll have your trusty calculator with you. To answer the question about on the homework, yes. On the homework, hold on one second, guys. Just let me put on mute for 1 second. Hold on. Sorry about that, everybody. Didn't mean to take a phone call. It was the landscaper, so just had to answer that question. Okay. On your homework, you have to put this, the interpretation, but on the exam, I'm going to ask you just basically to construct the confidence intervals. You won't have to do the interpretation on the exam. All right. Everybody feel good? Ready to go on to the last confidence interval topic? Speak now or forever hold your peace, as they say. Okay. All right. Last topic for confidence intervals. So this is what we've done so far. We've done for means. Okay, so for some mean. So all we want to do now is we want to talk about constructing confidence intervals for proportions. Okay. And it's actually pretty straightforward. Like there's not a lot of theory I'm going to talk about here. I'm just going to give you the formula, and then basically we're just going to jump right into examples because it's actually like pretty straightforward. So we'll end up doing one example by hand, and then I'm going to show you how to use your calculator because it's pretty easy. Okay, so confidence intervals for proportions. So just recall the sample proportion which we denoted as P with a little caret on top of it. Does anybody remember what we called that? What its name was? Yep, P hat. Thank you, Jamie. Yep, P hat. Sample proportion P hat. It's just equal to X divided by N. Okay. So N we know is the sample size. In X, all it is the number of individuals who have a certain characteristic. Okay, that's all it is. It's the individuals who have a certain characteristic. So this sample proportion is a point estimate for P, okay? And what P is the population proportion. And so imagine like you wanted to figure out the proportion of adults in the United States right now who have actually gotten let's just say a vaccine. Okay, like if you wanted to figure that out, there's like no way you could actually call every adult in the United States, right? So what you would do is you would take a sample. Okay, you'd call, I don't know, 1,000 adults and be like, hey, have you gotten your vaccine yet? Have you gotten your vaccine yet? Da, 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 da. And then you just count how many said yes, and then you take that number divided by 1,000, and that would be your sample proportion. And that would be a good single value estimate, okay, for the population proportion. But here's the thing, it's probably not the exact real value. Okay. So just like for means, a point estimate is a great single value estimate. But probably not the real value. Okay, so again, we can't know. Again, we probably cannot know the real population proportion. So again, what we do is we again estimate it with a confidence interval. And this is kind of actually pretty cool. If you've ever seen a poll in the news, it'll say something like, you know, oh, 50% of Americans approve of this or disapprove of that or whatever. But if you pay attention to how it's presented, what they'll always say is something like with a margin of error of plus or minus like 3%, something like that. And they usually throw that down in the corner of the screen. Has anybody ever seen that in a poll before where they say something like, oh, it's 48% of Americans approve of this, and then they'll say something like plus or minus, you know, a 3% margin of error? Has anybody ever seen that before? So not too many people chiming in, but like, here's the thing, like, I bet you all have seen it before. You've just not like registered it. Okay. So this confidence interval for it is just going to be the same, you know, same concept. So we're just going to need a formula for finding the confidence interval. And forgive me for 1 second. This little chart is actually on the wrong slide. So what I want to do on the next slide here is give you the formula for finding the confidence interval. So is everybody okay if I go to the next slide? Everybody can still hear me, right? Thanks. Oh man, remote teaching, right? And remote learning. Okay. So I'm going to go to the next slide now. So what this is now is this is the formula for constructing a 1 minus alpha times 100% confidence interval for P, okay? And P is the population proportion. So look, the formula, it's actually, you start the same exact way, okay? It's a range of values. Okay, so just like our confidence intervals for the mean, we're going to say you go from this lower value to this upper value here. So you're going to have a lower bound of the interval all the way to an upper bound. A lower bound to an upper bound. And you're going to start the same exact way. It's a point estimate. And you're going to add and subtract that margin of error. Okay. So the point estimate here for these problems is a sample proportion. And margin of error is always, always, always made up of two things. It's a critical value. And you're going to multiply that by the standard error. So this is the formula, okay? It's P hat plus or minus. The critical value is Z of alpha divided by 2. And the standard error It's the square root of p hat times 1 minus p hat over n. Okay. I know it looks kind of crazy, but it's actually like I actually think this is almost easier than the previous ones. Okay. P hat, that's just x divided by n. Okay. So I'll have to give you the information to find that. N is the sample size. And so the only weird looking thing is this z with the subscripted alpha divided by 2. And all this is a z critical value. Okay. And where did these z critical values come from? Right here. Okay, these are common z critical values. So for example, if I want a 95% confidence interval, okay, just go look on the chart here. What would the z critical value be? Just by a quick looking at it, what do you think it would be? Anybody? If I say I want a 95% confidence interval. Whoop. Thanks, Jamie. Yeah, it would just be this number right here. If I say I want a 99% confidence interval, it would be 2.575 and so on. So it's just those numbers straight from the table. Okay. So what I want to do with the time we have left is before our break is I want to show you how to do one example by hand, and then we'll do some examples just with the calculator. So it'll be pretty straightforward. Okay. Is everybody okay if I go to the next slide? Okay. I got one yes from Jamie. Oh, there's another yes. So I know at least 2 people are with me on this one here. Okay. So this next problem, what I'm going to do is I'm going to do the, thank you. Even Michael chimes in. So thank you. We got 3 people. We're going to do this by hand just so you can see how it works, and then I'll jump to the calculator. Okay. Bum, bum, bum. So here's the first problem. In a survey of 800 parents, okay, 632 said that music had a positive effect on academic performance. So I think what this means, this survey is saying is when they say music, what they're talking about is like music education, playing an instrument. All right. I used to play an instrument in school. Anybody got a guess about what instrument I played when I was growing up? Not the trumpet. Good guess, though. Maybe I have a trumpet personality. Tuba. That's a good one. No, that's a phenomenal guess, the tuba, but no. Drums, nope. I'll stop you. The flute, flute, nope, but not a bad guess either. I played the clarinet of all things. So that was my instrument when I was a kid. And the only reason I played the clarinet was because my sister played the clarinet. So it got passed down in my family. All right. But anyways, I just thought I'd share that. See if people laugh a little. All right. So here's the thing. That's just a sample of 800 parents. Okay. So let's construct and interpret a 95% confidence interval for the proportion of all parents who believe that music education here has a positive effect on academic performance. Okay, so the first thing we're going to do here first to do this, you're going to find p hat. So p hat is just x divided by n. Can anybody tell me what two numbers I would divide by here for this? Well, how many parents said that music does have a positive effect? Yeah, so you take 632 and you divide it by the 800 parents in the sample. So let's grab our trusty calculator here. Let's do 632 divided by 800. And you get 0.79, okay? 0.79. Okay. So now to construct the confidence interval. All right, you're going to use this formula. It's p hat, add and subtract the critical value times the square root of p hat 1 minus p hat over n. All right, so you're just going to take p hat, which is 0.79. And you're going to add and subtract. Okay, z of alpha divided by 2. This critical value right here, you got to go look back at this 95% confidence interval here. And all you're going to do is you're going to go back to this chart and you're going to say, okay, 95% confident, the critical value is 1.960 right here, 1.960. All right. Times now the square root of p hat, which is 0.79, times 1 minus 0.79 divided by n, okay, which is 800. All right, when you do this by hand, okay, you're going to have to find the margin of error first. So everybody grab their trusty calculator. Okay. So we're going to take this and plug it in our calculator. So I encourage you to follow along, but if you just want to watch me just so you can see, that's okay too. So we're going to go 1.960 times, now I have to do the square root of all of this. So second function square root. Now, if you have a TI-83, it's going to open up a set of parentheses here. Okay, just make sure if you have a TI-83, the last thing you do is close the parentheses. So this is 0.79 times 1 minus 0.79. I had to put that in parentheses. Divided by 800. Just out of curiosity, anybody following along get that number right there with me? 0.028. Anybody? Yay, one person. Okay, yes, great. All right. So that's my margin of error, 0.028. All right. That means my lower bound is 0.79 minus 0.028. You get 0.762. And the upper bound is the addition part. I think you get 0.818 when you do this. All right. So my confidence interval goes from 0.762 to 0.818. All right, so let me interpret this for you, okay? So this is saying, look, based on this sample, we are 95% confident that the proportion of parents, all right, who, who believe or who think music education has a positive effect on academic and performance is somewhere between, the real value is somewhere between 0.762 to 0.818. So basically, if you just want to see it as a percentage, it's like somewhere between 76.2% and 81.8%. Say like, yeah, it definitely has a positive impact, Hopefully my son wants to play the clarinet, okay? Okay. What do you think? Is it not too bad? Just a lot of calculator work? Feels like a lot of busy calculator work. What do you guys think? Okay. No, I'm not getting too much in the chat, so hopefully you don't think it's too bad. Yeah, it's okay. It's okay. It's all right. It's all right. So look, I only wanted to do this once by hand. Now I want to show you. You just got to figure out where things go. Yep, I 100% agree. Before I answer this next question, I actually just want to show you something to make this even a little bit easier on your calculator. Okay. So if you weren't following along before, please follow along now, because like the calculator is the default way we're going to solve these from here on out. All right, so grab your calculator like this. Okay, now everybody hit the stat button. You're going to scroll over to tests. And this is a proportion. So you might think this is this 1-prop z test, but if you scroll down, everybody scroll down on your calculator till you see option A here. Does everybody see in your calculator 1-prop z int? Can people let me know if they see that? I got one yes by Jamie. Anybody else? 1-prop z int. Okay. This is the option you're going to want to use. Okay. So in calculator, you went stat over to tests, and then it was 1-prop z int. Okay, now watch how easy this is. Under 1-prop z int, you're going to hit enter. And check this out. It's just going to say, okay, give me the x. Well, that was 632. N is the sample. So how many parents did you interview? It's 800. The confidence level is 0.95 because we have 95%. And look, 0.762 when you round to 3 decimal places, 0.818. Boom. Just like that. So much easier, right? Well, I want you to know the calculator is actually doing something behind the scenes, like, what would be funny if like the review of this class would be like, super confused. I'm going to do that again in a second. No problem, Alexandra. The review of this class should be like, it's somewhat confusing until Matt shows the calculator, and then it's a piece of cake. Alexandra, so what you were going to do is you'd go to stat, you'd go over to tests, and you scroll down till you see this thing called 1-prop z int. 1-prop z int. And then you put in the x, the n, and the confidence level and hit calculate. And I'm also going to do 2 more quick examples of this for you before we take our break. Okay. So I promise you it'll make sense. Is that okay, Alexander, to put this down? Yep, great. Okay. So look, before we do the next 2 examples, let me just ask you this. Okay, this is this next follow-up question. So imagine there's this music teacher, okay, and he or she, this music teacher says, hey, I know for a fact that 80% of parents believe that music education has a positive effect on academic performance. So he or she, the music teacher, is saying 80% of adults. So let me ask you this. Does the confidence interval support or contradict the teacher's claim? Okay. So this was the confidence interval, 76.2% to 81.8%. So here's how you figure out if it supports or contradicts. Okay. Look, this confidence interval is saying, look, it could be any value in between here. Okay. In between 76.2 to 81.8. Does 80% fall in that confidence? Does 80% fall between those 2 numbers? What do you think? Does 80% fall in between those 2 numbers? Yeah, sure does. So since 80% is within the confidence interval, it supports the claim. Because you know what? It could be 80%. It absolutely could be 80% because 80% is in there. All right. So it supports the music teacher's claim. Yeah, sure. It could be 80%. I can't say it's not 80% because 80% is in that interval. Okay. You ready to see 2 more quick examples of this? What do you all think? Ready for the next example? I got 1 yes. I know what's going on in class today. Everybody's excited that baseball season has started and they're having a hard time concentrating. I understand. Me too. All right, here's the next question. I'm a huge baseball fan. I love baseball. All right. I think, let's see. Oh, I'm not wearing my Bryce Harper t-shirt today, but I was yesterday. All right, here is the second example. So in a recent survey of 600 WCC students, okay, so this is my N. Okay, this is my sample size. It was found that 350 use social media daily. So this is my X, okay? Let's construct, I'm only gonna construct here. We don't have to interpret. Let's just construct a 99% confidence interval for the proportion of WCC students that use social media daily. All right, so for this one here, we're gonna use our calculator. Okay, so the options are, you're gonna press the stat button, you're gonna scroll over to tests, and then you're gonna always scroll down to 1-prop z int. Always, always, always. And then once you see this, like this is literally how easy it is, okay? So you're gonna press your stat button, scroll over to tests, and it's 1-prop z int. So 1-prop z int. So it was found that 350, there were 600 students. And then do I have to change the confidence interval here? Do I have to change the C level here to anything? Yep. Awesome. Thank you, Jamie. Yep. You just have to change it to 0.99 because I asked for a 99% confidence interval. And then just hit calculate. Literally, boom. Look, wow, bam, right there. Done. That's your confidence interval. Yeah, I agree. I agree. So look, it's 0.531 to 0.635. So basically for your last test, you're going to get a question just like this on the test. Okay. So really, I think what tends to make this hard is if you just got to know what it's asking, right? Like, how do I know it's a confidence interval for a P and not a T? Like, that I think is the hardest part. But once you figure that out, then it's just right to the calculator and boom, 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 boom. Okay. Not too much more to do on this one. You ready for our last confidence interval example here? So I'll get through the next example, then we'll take our break. Okay. All right. So here it is. A certain WCC professor believes that less than 50% of college students watch the online lectures their professors post. That's travesty. That's terrible. Okay. So to test his belief, okay, this certain professor, okay, no relation to me, okay, he samples 500 college students, okay, and finds that 240 watch the online lectures posted by their professors, okay? So does this provide evidence to support the professor's belief, okay? So here's what's going on in this problem. This professor is saying, oh, the grumpy old professor saying, oh, less than half my college students watch the online lectures I post. And I don't know why I made that voice. Okay. I have no idea why I made that voice and visualized him as an old grumpy professor. But I don't know why that's sticking in my mind here. Anybody find that funny that that's where I go with this? Okay. All right. So what he does is he samples 500 college students, right? And the professor, the sample proportion the professor comes back with is 240 out of the 500, which ends up being 0.48. Okay. So that's less than 50%, right? Okay. So this is also an indication, like whenever you see a poll and it says something like, oh, less than half of Americans support this policy. Well, you got to dig deeper, right? So look, here's the thing. This is just one random sample of 500 college students. So based on this sample, okay, what could the real values be? Okay. So it says use a 95% confidence interval to test this pet professor's, what the professor believes. Okay, so we're going to use this options in the calculator. Stat, tests, 1-prop, z int. Okay, let's just plug in the professor's data and see what happens, okay? So click stat, go over to tests, Go down to 1 dash prop z int. And look, let's put in 240, the 500 college students. We said do a 95% confidence interval. Now let's calculate and see what we get. How many people got this right here? Anybody else get what I got? I got Jamie did, yeah. Anybody else? Okay. All right, good. Bunch of people. So look, 0.436, this is what the confidence interval was. 0.436 up to 0.524 when I round it. Okay. So look, this is what's going on with this confidence interval. We're saying, look, I have no idea what proportion of college students watch the online lectures their professors post. I don't know. But this professor, for whatever reason, believes it's less than 50%. Well, I took his survey, and based on his survey, this is how you would interpret this, right? We are 95% confident that the proportion of college students who watch their online lectures is between 0.436, okay, which is 43.6%, to 0.524, which is 52.4%. All right. Okay, but so close, Jamie, right? So like 0.48 is just the point estimate that the professor got, okay? But like, so the real value could be anywhere as low as 43%, but the real value could be as high as over 52%, okay? So do you notice how the professor says he believes that less than 50% are watching the lectures? Could the real value, based on the confidence interval, could the real value actually be above 50%? Like, what do you think? Yeah, totally. Notice how the confidence interval goes above 50%, okay? The real value could be above 0.50, okay? So even though the professor got a point estimate of 48%, the evidence does not support his claim. All right, good. So that's why it's, you guys ever see polls like in the news when they'll say something like, oh, there's this poll and it said 49% of Americans support this policy. And they're like, well, less than half support the policy. It's like, well, you got to kind of look at the numbers and understand the statistics behind it, because that's misleading. So you really got to look at that margin of error in this type of stuff when the polls, when you look at, survey research and stuff. All right, but regardless of that, is it at least pretty easy using the calculator? Boom. Awesome. I got one yes. All right. What do you think? Okay, time for a break? I think it's time for a break.
Professor, if it falls below 0.48, then he is right.
So if the confidence interval had been something like this, 0.40 to 0.49, as long as the confidence interval is below 0.50, then he would have been right.
Okay, yes, below 5. Yeah, okay.
Yeah.
Because he said less than 50%.
That's correct. Yep.
Thank you. Got
You're
it.
welcome. All right, let's take our break. Actually, let's take our break and let's come back at 2:08. We'll come back at 2:08, everybody. All right, so enjoy your break. I'll see you in 10 minutes. All right, everybody. Can everybody hear me okay? Just checking my mic again.
Yep.
Is that we're good?
Yep.
All right. So guess what? This is it. Our last topic of the class. Woo! Am I the only one who's excited about this?
Oh, very.
I hope you guys are excited. You know, it's crazy. Like this semester was crazy, right? Like it felt like it went super fast. I don't know how other people felt. Even with losing like we had no spring break. So it was like just straight right through, but like we had 2 weeks left of school. It's like insane. Yeah, it did go super fast. I hope everyone had a good semester. I know remote learning is challenging and stuff, but you know, they're you know, next semester they're starting to bring classes back on campus. So you know, if you want to get back on campus, you can get back on campus. Yeah, got to make the best of it. Absolutely, I agree with that. Or you know, if you like remote teaching or remote learning, you know, then there's still tons of opportunities. You know, next semester to stay at home and learn if you want. You know, me myself, I will be teaching remote again.
I think all the professors did so well with this remote learning.
Really, that's great to hear.
Yes.
Yeah, it's like a challenging thing, right? But I'm really glad to hear that professors have done well. You know, it was such a crazy time this last year. It's just been like so weird. Um, it's so funny. Like I'm gonna have to tell my son about this. You know, like you were born in the middle of a pandemic, and what was it like? You know, that's good. I'm glad professors are being positive. Yeah, yeah. It's hard not to be. I would think most of us really like our jobs, love our jobs. So it's easy to be positive. At least I hope. All right. And I hope you guys are all staying positive. Let's do it. Let's jump into our last topic. So let me just say this. The next 30 minutes or so of class is just going to be one of those classes where I like give you the theory and the terminology behind it. And then we're actually not even going to do an example of this hypothesis testing until we come to class on Tuesday. So we're going to get all the terminology out of the way. And it's really important that you pay attention because the terminology is incredibly important for hypothesis testing. So, so just, you know, you can put the calculator down. We're not going to use it until Tuesday, but jump right into it. Okay, so hypothesis testing, 2 words, hypothesis and then the testing part. So first off, this is, as I was saying, this is our last topic. This concept of hypothesis testing. And we're going to do 2 types of hypothesis testing. Okay, we're going to do hypothesis testing for a mean. Okay, so for an average, and then we're going to do the last topic is going to be hypothesis testing for a proportion. Okay, so what is a hypothesis? Have you guys heard this word before, hypothesis? You know, when you hear the word hypothesis, you know, what do you think it is? What do you think it means?
I think you're generating like a question or an inference.
So you're generating an inference. So like what you're doing when you have a hypothesis, yep, an educated guess. Like, you know what, here's this problem. I think this is the solution to it. Okay, that's generally like, you know, the way you've looked at hypotheses, like in your science classes and things. So in statistics, it's a little bit different, okay? So in statistics, a hypothesis is a statement regarding the characteristic of a population parameter. Okay, so a statement regarding the characteristic of a population parameter. So population parameter. So what are the population parameters we're going to be testing? So recall. So we have the population mean. That's the Greek letter mu. It looks like a U, okay? And then we're also going to be testing things for the population proportion. Which is P. Okay, so what I'm going to be doing here is I'm going to be making a statement regarding the characteristic of this. So really what's going to be going on when I say the characteristic in stats class, it's going to be the value. Okay. I'm going to say something like, I think the population mean is equal to this, or I think the population proportion is equal to this, or I think it's greater than this number, or I think it's less than this number. So those are the type of statements we're going to make. And what our goal is going to be in this whole section is going to be to test the statement. Okay, you're going to test the statement. So we're going to have this hypothesis, and then the testing part is going to be how we go through and actually test this statement. All right. Is it okay if I go to the next slide?
Yes.
I got one yes. Hopefully. Okay. So here's the thing. What exactly is hypothesis testing? So it's a process to test the validity of a claim, okay? So hypothesis testing in statistics is a procedure. So and there's more to this, but I'm going to probably won't get to it today, but next class, what I'm going to do is I'm going to teach you the actual procedure. So like there's this, what you'll notice, and I'm going to say is this 5-step process for hypothesis testing. So hypothesis testing is a procedure based on sample evidence. Okay, so basically there's more to this. To test the validity of a claim, what you're going to have to do is you're going to have to collect evidence, right? You want to have evidence that supports the claim or evidence that does not support the claim, okay? And so in statistics, what our evidence is going to be is sample data. So sample evidence or sample data, okay? So it's a procedure based on sample evidence used to test a statement about the characteristic or value of a population parameter. All right, so let me give you an example about a claim, okay? So here's why we would need hypothesis testing. So a recent study said that on average, college students watch an average of 20 hours of TV per week, okay? So just out of curiosity, just a real quick like straw poll in the chat here. I mean, Do you guys think college students here at WCC watch less than 20 hours of TV a week on average? What do you think? Does 20 seem high to you? Like it totally seems high to me, right? Like I don't know about you guys, but do you guys feel like you're super busy and don't have time for anything these days? Like just the nature of like yes.
Absolutely.
A lot of yes. Jamie, you're like, yes, yeah, yes, totally, and too much, don't have any free time. Wait till you have a young child, and then, I don't know if anybody else has young children in the class, but I'll tell you, my free time, pre-kid, post-kid, 0. Okay. Not that I'm complaining to you guys, although it does sound like I am, but so, yeah. So a professor at WCC thinks the mean hours of TV watched per week by WCC students is less than 20. I'm like, no way. College, you guys got to watch less than 20 hours of TV per week. This right here, this less than 20, this is Matt's claim or the professor's claim or his hypothesis, his or her hypothesis. Okay. So let's just say the professor's me. Okay. It's like, oh no, I think they watch less than 20 hours of TV per week. Okay. So that's my claim. Okay. Now here's the thing. His claim, Matt's claim, okay, can either be true or false. So when I make a claim here, it can either be correct that you guys do watch less than 20 hours of TV on average, or it could be false. Maybe you do watch 20 hours of TV on average, or maybe even watch more. So this is the whole point of hypothesis testing. I'm going to make this claim, and I need a method to test this claim, okay, this hypothesis. And this is what we're going to do next week, is I'm going to show you this method. All right, and this is just a little bit of a preview, but it's going to be a 5-step process. And just like with confidence intervals, the hardest part of hypothesis testing when I get to the procedure, it's never like the math part. It's never like, because I'm going to show you how to use the calculator. It's never any of the calculations that are hard. It's always like setting up the problem, figuring out what numbers to plug in correctly in your calculator. That always ends up being the hardest part here. Okay. So we're going to have this procedure to test a claim. Okay. So one of the most important things is setting up the test. Okay. So is everybody okay if I go to the next slide? Everybody good? Next slide. Boom, boom, boom. Okay. So setting up the test. Now, this is, again, the most important. Okay, if you can set up a hypothesis test correctly, at least in our course here, generally the rest of it just falls right into place. Okay, so when I make a claim like this one, that you guys watch less than 20 hours of TV per week, WCC students, okay, my claim can either be true or false, right? Like I'm either correct or incorrect. So when you set up a hypothesis test, you need 2 statements, okay? So you always need 2 statements. Always need 2 statements. And the first statement you need is what's called the null hypothesis. Okay. And this is denoted with an H with a subscripted 0. Okay. All right. Now this null hypothesis is a statement to be tested. Okay. Now here's the thing about the null hypothesis. All right. The null hypothesis is assumed to be true until evidence suggests otherwise. All right, think of the null hypothesis as your base starting assumption, okay? So you're gonna, whenever you set up these tests, you're always gonna have some base or starting assumption. And then you're gonna set up another statement that's called the alternative hypothesis. Which is going to be denoted as H sub 1, with H with a subscripted 1. Okay. This is also a statement to be tested. And what's going on with the alternative hypothesis is you are looking for evidence to support the alternative. Okay, so it seems weird, right? Like, what do you, so it's like, Matt, what do you mean we need two statements, right? Like, why, what is this null, some base assumption, and then what is the alternative? Okay. So this is kind of like, this is weird. Okay. And let me give you an example of why you need this. Okay. Consider our criminal justice system. Okay, so actually, believe it or not, when somebody's put on trial, okay, there's actually a hypothesis test going on. Okay. So think about this. Imagine I'm arrested and put on trial for something. Okay. Like maybe I'm put on trial for being too awesome of a statistics instructor, right? Like that's a crime. Okay. You guys, no LOLs, no funny jokes there. Nobody found that funny. Okay. Anyways, thank you, Storm. I appreciate the pity LOL. All right, but in all seriousness, imagine I am put on trial for a crime. Okay, would probably be like a white collar crime or something like that. Okay, embezzling or something. Okay, but when someone's put in front of a jury in our criminal justice system, what are they told to assume? Like, what are they told to assume? You're assumed what at the start of the trial?
Not guilty.
Yeah, you're assumed innocent. So when you go to a jury, when you go to under trial, this is the null hypothesis. You're assumed innocent. So that's the null hypothesis until evidence. Okay. What are we looking to show evidence for when someone's put on trial? So they're assumed innocent until evidence shows that they're
Guilty.
guilty. Yeah, that's it. So here's the thing. In the criminal justice system, we have a null hypothesis and an alternative. Okay, so this is how we're always going to write these, okay? You're going to have your null and then your alternative with semicolons like this, okay? Colons, excuse me. And what it is defendant is innocent. Okay, so you assume the defendant is innocent. That's the null. That's your base assumption, so assumed true. And then you're looking to show evidence for the alternative that the defendant is guilty. Okay. So base assumption. The null. And the alternative you're looking to show evidence for. So whenever we set these, so it's incredibly important. Whenever you set up hypothesis testing, you have to have a null and an alternative. A null and an alternative. Okay. All right. Let me know if it's everybody okay if I go to the next slide. Me, yes. Okay, got one yes. All right, so sorry for you guys hear the noise in the background? Sorry about that. There's just a little bit of construction going on in my house, so sorry about any noise you hear. Okay. So what are the conclusions to make in hypothesis testing? So we use very, very specific terminology, just like they do in the criminal justice system. When somebody is put on trial, you're either found guilty or what is the other outcome? You're found guilty or what?
Innocent.
Well, here's the thing. Do they actually say you were found innocent?
No, not guilty.
They say you're found guilty or innocent. So like they use very specific terminology. So the reason they do that is because the reason they say we found you not guilty is because they just didn't have enough evidence to say you were guilty. Okay, they can't say for sure that you were innocent, right? Like, you know, they're just saying, look, we didn't have the evidence, so you're not guilty. They never say innocent. Okay, so there are two very specific conclusions you can make in hypothesis testing. Okay, so there are two conclusions you can make. Okay. The first one is we can do what's called reject the null. Okay. So when you reject the null hypothesis, what this means, going back here, we're rejecting this. We're saying, no way, this is not true. Okay, so when you reject the null, what's going on is evidence supports the alternative statement or the alternative hypothesis. Okay, so when you reject this null, you're saying, like, if for the criminal justice system here example, when this is very akin to saying the defendant is guilty. Okay, the district attorney or whoever was prosecuting the case, you know, found enough evidence to say, yeah, you're guilty. So the other outcome that you can make is you can do what's called, you can fail to reject the null. Okay, what this means is evidence does not support the alternative. Okay. What this means here is that something like the defendant is not guilty. Okay, so basically what happens is the person was put on trial, and when you fail to reject the null, you were saying, look, there's no evidence. You didn't put enough evidence forward to say that the person actually committed the crime. Okay, that's what's going on here. All right, so again, what is our evidence here? All right, our evidence is sample data. Okay. So basically in statistics, hypothesis testing is going to follow these steps here, okay? You're going to make a claim. Okay. In this case here, the claim for this one is this defendant committed the crime. Over here, the claim is, hey, look, that the WC students watch less than 20 hours of TV per week. That's my claim. Okay. after you make your claim, you're going to collect sample evidence. All right, in this case, my sample evidence is my data. And then the third thing you're going to do is you're just going to analyze the evidence. Okay, in this case, the analyzing the evidence involves like, does the data support the claim? And so what's going to happen in this class is, for the examples, I'm actually going to give you the data in the claim. What we're going to spend time focusing on is, the steps and procedures for how you analyze the evidence. That's what this next week is going to be all about. All right, actually, if it's okay with everybody, I actually think this is a good place to stop. Would anybody be mad if we ended class about 15 minutes early?
Very upset.
I don't want to get a little disjointed with the next steps and not be able to finish it. So we're actually like in a really good spot, like actually ahead of where I thought we would be. So I think we'll actually end class 15 minutes early, if that's okay.
Thank you, Professor. Have a good day.
Okay, all right. We'll pick up here on Tuesday, and I'm going to teach you on Tuesday how to actually set up the hypothesis test. So everybody, I'll post the recording in a little bit, and everybody have a good rest of your day.
Have a good
You
day.
as well. Thank you.
Thank you.